In the last video, we thought about whether ASS was a good enough set of rules to guarantee that two triangles were congruent. And we saw an example in GeoGebra where it wasn't, where that's not enough information. And so what we're going to do is we're going to look at a specific case where it does work, and we're going to come up with a separate name for it. And so this is going to be our fifth and final triangle congruence criterion. So let's pop over to all right, so this time, what's different about this situation is that the two congruent angles between A and X are both right angles. All right, so these are right angles. And once again, we have two congruent pairs of sides. So AC is congruent to XZ. They both have length 4. And BC and YZ are congruent. They both have length 5. So let's ask ourselves, what if I wanted to find, let me call this little c and let me call this little z, and see what can I do to calculate what c and z are equal to? Well, what do we know that lets us calculate things knowing the sides of a right triangle? Well, we know the Pythagorean theorem. And so the Pythagorean theorem says that if you square the two legs and add them together, you're going to get the square of the hypotenuse. So in this case, we've got c squared plus 4 squared is equal to 5 squared. And we can see if we can solve this for c. So c squared, 4 squared is 4 times 4, which is 16. 5 times 5 is equal to 25. If we subtract 16 from both sides, we get that c squared is equal to 9. And what positive number has a square equal to 9? Well, 3 times 3 is equal to 9. So we know that c is equal to 3. All right, same thing over here. So we've got z squared plus 4 squared is equal to 5 squared. This is going to look very similar. So z squared plus 16 is equal to 25. Z squared is equal to 9, and therefore z has to be equal to 3. All right, and there's nothing special about the numbers 4 and 5 here, except that it makes the numbers happen to work out. But as long as we know that the two legs are congruent and the hypotenuses are congruent, you can use the Pythagorean theorem to solve for the missing leg. And so the missing leg has to be the same in those two triangles. All right, and so we want to come up with a name for this, which isn't angle side side, because angle side side doesn't work. So our angle always has to be a right angle. So I will start with R for right angle. And this is a hypotenuse and a leg. All right, so if we know that two triangles are right triangles and they share a hypotenuse and a leg, that is enough information for us to prove that two triangles are congruent. And what you'll often see people do is they will take off the R and just call this the HL theorem. So all you need to know is the hypotenuse and a leg, but the word hypotenuse only makes sense if it's a right triangle. Okay, so let's take a look at what we've got. So here are our 5 congruence theorems. We've got SSS, SAS, ASA, AAS. We figured out that this was not a triangle congruence theorem, but HL is. Okay, so here are our 5 congruence criteria. And the only reason I like calling this RHL, and I'm pretty alone in this, is that you notice that all 5 of those systems all have you needing to prove 3 pieces of information. In SSS, you need to prove 3 pairs of sides are congruent. ASA and AAS, you need to prove 2 pairs of angles and 1 pair of sides. SAS, you need to prove 2 pairs of sides and 1 pair of angles. And HL, you need to prove that they're both right triangles, that the hypotenuses are congruent, and that one pair of legs are congruent. So in each one of those cases, even though a triangle has 6 parts, 3 sides and 3 angles, in our 5 congruence criterions, we only need to show up with 3 pieces of evidence for each one of them. All right, so that's all of the triangle congruence criteria that we are going to talk about this year. Later on in the year, we'll talk about separate criteria for proving that triangles are similar, which means they're the same size but different, the same shape but different sizes. But that will come in the spring. So right now, only work on memorizing these 5 different congruence criteria. And it's easy to remember the one that doesn't exist because it's the one that's a bad word.